Hi, everyone. Since we lost this week, I thought you could use a little bit more practice so you could be successful in your worksheet number 4. And so this is just practice. There's similar problems to the problems on your worksheet number 4. I have a unit circle here. You want to have that out, all right? You want to have it memorized by midterm time, but right now just have it out and get used to it and refer to it often. So this says find the exact value without using the calculator. So I want to find tangent of negative pi over 3. So what we're going to do is we always start here. Okay, that's always, because we're always looking at angles and standard position. To refresh our memory on that, standard position means your vertex is at the origin. You start on your positive x-axis and you go counterclockwise for positive angles. And then you go clockwise for negative angles. So if this is negative pi over 3, I'm going to start here. Let me choose a better color. Start here. Positive pi over 3 goes from here all the way there. That angle, just so you realize what we're looking at, this angle is 60 degrees. In radians, it's pi over 3. So that's what that marking is telling you. And we already learned that our sine value is our y coordinate if it's on the unit circle, and it's our x coordinate for cosine. Tangent, we talked about, is sine divided by cosine. Another way to look at that is y over x. Again, the best part about this class is when in doubt, create a triangle. So this, remember how we created our unit circle. We created it using those special right triangles. So remember, if this is our angle and we're standing here, this is where we are. Opposite over adjacent is tangent, right? And that is our x, y, and then this is our hypotenuse or our radius of our circle. Okay, so refreshing your memory, all of that stuff. I'm going to go ahead and take this stuff away so it doesn't get too messy. So if I want to go negative pi over 3, well, I start here, but I have to go negative. So I go and then I stop here. So it's the same angle, it's just in a different direction. So it's like taking a left versus taking a right. Okay, well, I have this coordinate, and that's going to be, and I'm going to put an equal sign, sine or y over cosine or x. Okay, well, when we divide fractions, I'm going to make this a little bit messy, or maybe I can put it all on. Let me go ahead and take away that equal sign. When we divide fractions, we multiply by the reciprocal. Those 2's reduce out. So tangent of negative pi over 3 produces negative root 3. So I want to see this work on your worksheet, okay? Because we could just plug these into the calculator, but that's pointless. That's not what we're learning here. You can do that to check your work, make sure you got it right. But I want to make sure that you show all your work when you can. Sometimes we can't. Okay, now for the second one, sine of 17 pi over 4. So what I want to do is I want to go ahead and rewrite this as a mixed number. Another way of saying that is a proper fraction. This is an improper fraction. So you got to get better with fractions because I think we all struggle with them. 4 goes into 17 pi 4 times. Well, 4 times 4 is 16. So we have 1 left over. Now, there's a couple ways to look at this. Is I can just do that verbatim. So it says, I want to go around, it says 4 full revolution, 4 pi, sorry, don't look at it that way, 4 pi plus another pi over 4. So what I'm going to do is start here, and this is the big thing. When you go around this circle, that is 2 pi. Well, I need to get to 4 pi. So that's why I'm going to go around one more time. That's 4 pi. Then I need an additional pi over 4. So I stop right here. The other way you could look at it is, well, if you remember your period for sine is 2 pi, well then I know, remember, period is when it repeats itself, all those lovely things. So I could say, okay, well, I could take away that 4 because I know that's just going to be the same value no matter what. That maybe we're not ready for that. So I'm going to continue to just do it verbatim. So if I look here, my sine is my y value, so it's √2 over 2. All right, let's get rid of this thing so I can see things. I'm going to put it over here. And let's go ahead and erase some things so we can see it. I've already gotten that, hopefully. Sorry about that. Louis wanted to do some trig with you all. Okay, so now for 3. It says 6 times the value of tangent of pi over 6 plus 2 times the value of sine of pi over 3. All right, well, I'm just going to rewrite this equals 6. Now I'm going to evaluate this. So I need to go to pi over 6, which is right here. And we need to find tangent. So that's going to be y divided by x plus 2. And then I'm going to times it by sine of pi over 3. So I need to go to pi over 3. And my sine is my y value. So that's √3 over 2. Equals, well now I'm dividing fractions, so I'm going to multiply by the reciprocal. And then this is kind of nice. These 2's will reduce out. Well, what happens here, these 2's reduce out too. And I end up getting 6 times 1 over √3 plus √3. All right, well, remember, I can't leave a radical in the denominator. So I'm going to rationalize that. I'm going to skip that step because hopefully you're feeling better about that. So that's going to be √3 over 3. And of course, I didn't give myself enough space. All right, so now 6 times √3 over 3, we'll realize that the 3 can go into 6 2 times. So I get 2 √3 plus √3. So this is really nice because it's really giving us practice with fractions, radicals. A lot of previous math classes are going to come up, and this is what happens in calculus too. All of those classes you took are finally going to pay off. So you have 2 √3 plus 1 more, and so that's why your final answer would be 3 √3. I'm just going to move this down here. Okay, now I want to go secant of negative 450 degrees. So let's go ahead and get rid of this stuff. All right, so I have to go negative, so that means I'm going to go clockwise. I always start here. If I go around this circle once, that's 360. All right, well then I need to go, if I go another same direction, let me notate that I went around once. So that's negative 90, right? Well, isn't negative 360 minus 90 negative 450? So you want secant of that. Now remember, secant is your reciprocal for cosine. So cosine's my x value. Well, what's the reciprocal of 0? That is undefined. Right? Because we can't divide by 0. All right, I'm going to go ahead and get this rid of this guy, move it so I can see things again. and then erase things. Forgive this, it's not the best. I'm making this video very quickly. Okay. All that stuff, get rid. All right, let's actually just move this up here. Okay. Now, cosine of 420 degrees. So once again, I need to go around the circle once. So if I go here, go around positive, so I need to go this way. That's positive 360. And then to get to 420, I need an additional 60. So let me actually write that out so you can see it. So what I'm doing is I'm breaking this up to be one full revolution. You don't have to show that work. I think it's helpful, but you don't have to. Okay, so now I know I end up here, and this is my cosine value, so that equals 1/2. It's kind of fun. It's like a little puzzle. All right, let me go ahead and get rid of that for the next one. So now I need to find cotangent of -5π/4. Well, here's the thing. From here to here, that angle is a positive 225 degrees. In radian world, it's 5π/4. I need to make that same big angle, but in the different direction. So you need to travel just as much. So I go here, I start here. I keep going, I go through half the circle. And then it looks like I do an additional, whoops, not that, additional 2 more. So I end up here. So that's the thing that confuses some students. Positive 5π/4 was that yellow line. I need to go in the different direction, but I need to make it as big as the first angle. So you have to go the same amount of distance, I like to say, around the circle. All right, well, cotangent is the reciprocal of tangent. So remember, tangent was y over x, right? Or sine over cosine. Well, now I'm going to do the reciprocal. So that's why it's going to be -√2 over 2 over √2 over 2. Well, the same thing divided by the same thing is 1. There's a negative divided by a positive, so we get -1. Cosine of 5π. This one, pay attention. Remember, when you go around the circle once, that is 2π. All right, then I got to go around again. That is 4π. Then you got to get to 5π. Let me choose a different color. So now I'm at 4π. If I go 1/2 of a circle, that would give me 5π. So I end up here. Another way we could write this, if you want to write it out algebraically, is 4π plus an additional π. Because you know, if you have an even amount of pi's, you're always just going to land here, the starting point. Because around the circle is 2π. So 4π, you're just going to end up there. 6π, you'll end up there. Odd number of pi's, you'll always end up here. So now my cosine value is my x, so that's going to equal -1. Okay, 8. Cosecant of 15π/2. Well, I like to rewrite this as a mixed number. So 2 goes into 15 7 times with 1 left over. So I'm going to go ahead and get rid of this stuff just so I can start fresh. It's nice working on a tablet. Okay, so 7, I need to go around 7π. So that doesn't mean 7 times. Be careful of that. 1 revolution is 2π. I'm going to go around again. 4π. Go around again. 6 pi. But then I need, let me choose a different color so it all stands out. I need to get to 7 pi, so I go here. So this is 7 pi. So I just said, you know, if you can remember it and it clicks in your brain, don't just memorize something. Remember, odd number of pi's end up here, even amount of pi's end up there. It's a nice little trick. All right, but I don't need just 7 pi. Now I need from where I stopped, because this is where 7 pi is, I need to go an additional pi over 2. So where you stop, then you have to go an additional pi over 2. So you end up here. Cosecant is the reciprocal of sine. Well, my sine is -1. So it would look like this, 1 over -1, which is just -1. All right, so one more example to help you with your worksheet is now you're going to have something that is not on the unit circle. So this is the biggest problem. As students will see this and think, oh my gosh, cosine of theta is -2, sine of theta is 3. That's not true. That is only the case when you're on the unit circle because your hypotenuse is 1 and you're dividing by 1. Remember, because sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, so that works out. I don't know what my hypotenuse is here. So what this is saying is you're in a standard position. You also had an example like this in your notes too. And it says my angle, theta, this is on the terminal side of my angle. So if you think about a Cartesian plane, and remember, we're always in standard position. So I start here. This is my initial side of my angle. -2, 3. Well, here's -2, 1, 2, 3. Here's that coordinate, -2, 3. My terminal side of my angle goes through it. And this is the theta they're talking about. Well, just like your unit circle, let's get a different color, created a triangle and used our reference angle to help us. Remember, this is our reference angle. Reference angles never go away. We're going to refer to them a lot. All right, well, we know this length is -2. It's just talking about going left versus right. And then we know the height is 3. And how could you find your hypotenuse? So you could label this R or H, whatever you feel comfortable with. Well, if I want to find that R, because think about, like your notes say, we can make a circle here. So that's why it could be R, or you could look at it as hypotenuse for your triangle. Well, we used Pythagorean theorem. So 3 squared plus -2 squared equals R squared. So we get 9 plus 4 equals R squared. 9 plus 4 is 13. And then we take the square root to get R by itself. Now remember, if that square root was like 24, you have to simplify it. So, you know, that would become 2 root 6. So just make sure 13 is prime, so we're good. We don't have to do much more. But don't forget about those previous skills from other math classes. So I'm going to go here and I'm going to label this is root 13. Well, remember, we use our reference angle to help us figure out values. So sine of theta, I'm looking in that triangle from our first day we met, that's opposite over hypotenuse or your radius, however you want to look at it. I can't leave it like that. I've got to rationalize always. So we get 3 root 13 over 13. Okay, cosine theta is adjacent over hypotenuse. Rationalize it. I'm going to save us some time. -2 root 13 over 13. Tangent of theta is going to be opposite over adjacent. Or you can look at it as y over x. All right, we have to find 6 of them. So we need to do the reciprocal functions. So cosecant of theta. This is the nice thing. Go ahead and take this reciprocal, right? Because I don't want to have to rationalize and simplify things if I don't have to. So that would just be root 13 over 3. Another way I could have looked at that is the definition of cosecant is hypotenuse over opposite, right? Because it's the reciprocal of sine. Then I have secant theta, which is going to be root 13 over negative 2. And then cotangent theta is the reciprocal. You can look at it 2 ways, the reciprocal of this thing, or it's adjacent over opposite. Now, one thing I want to make clear is make sure you have thetas. These functions are not defined if they don't have input, okay? So I will take off points because this means nothing. There's no input. So like think about a computer program, it won't work. So just realize that it's incorrect. So I hope this helps, and reach out if you have any questions. Oh, sorry. Get me out of here.